So there were a couple of questions on the MSL 8 that gave folks some trouble, and I just want to cover these just to show you how to do them, make sure you know how to do them so that when you take the exam, you're in a better position. These are two of the longer questions, so they have several parts. We can look down here and see that there are 8 parts remaining. So I'm going to work number 4, and then I'm going to work number 7. And just go ahead and do it. Now, every time you generate these, you get a new set of data. So I want to go ahead and be fair about it and just do the whole process and get the data and show you how to do it. Now, there are ways of calculating these things, using equations from the slides. And I showed you how to do that, but we're going to go ahead and use the shortcut real world way of using Excel. Okay, all right, so a problem with a telephone line that prevents a customer from receiving or making calls is upsetting to both the customer and the telephone company. Samples of 20 problems reported to 2 different offices. Okay, so clearly a t-test situation, 2 different offices, independent. 2 different offices of a telephone company, and the time to clear these problems in minutes from the customer's lines are provided. Okay, so this is going to be an independent samples t-test. We'll go ahead and get the data. So this is the office number 1. So I'll just go ahead and get this the way that I like to do it, and we'll put that in Excel. Okay, so we'll call this office 1, and we got their times. Okay, and this is office 2, so we'll get that data. Okay, we'll call this office 2. Put that there. Okay, so we got the data to start with. Let's go ahead and do these questions one by one. So we're going to assume that the population variances are equal, so we'll do that equal variances test. Is there evidence of a difference in the mean waiting time between the 2 offices? Okay, so classic 2-tailed independent samples t-test with an alpha of 0.05. Okay, so let mu1 be the mean waiting time of the first office. Remember, these are samples, so we're actually hypothesizing about the difference in the population means using the sample means as a evidence. Okay, so it's a 2-sample test, so the hypotheses, and I think everyone got this right. So the null hypothesis is going to be that there's no difference between the 2. We don't have any reason for a directional hypothesis that 1 is better than 2, so we'll just go ahead and do equality versus non-equal. Okay, all right, so there's that. Okay, so now determine the test statistic. Okay, so this just means to do the t-test and come up with the test statistic. We're going to use Excel. I'm sure most of you did it this way. We're just going to use the data analysis tool pack and do the t-test 2 samples assuming equal variances. Okay, we're going to put office 1 here and office 2 here for our second variable. Okay, and because it's a 2-tailed test, and we're including the case of equality, so it's going to be 0, the hypothesized mean difference. We did include the labels in our select, and we were told to assume an alpha of 0.05. Okay, so we've done the t-test. Okay, now it looks like they're going to ask us to round to 4 decimal places, so I'm just going to take a little shortcut here and have everything rounded to 4 decimal places for me. Okay, so what is the t statistic? Well, it's right here, 0.4753. Okay, that's very small. I mean, a t statistic that would lead to rejecting the null hypothesis would be like greater than 2, but so we can tell right away that this is going to be a fail to reject situation. So 0.4753, 0.4753. Okay. All right, so now we have to determine the critical values. Now, Excel gives us these, and all we have to know is that we're doing a 2-tailed test. And so with a 2-tailed test, remember, Excel only gives you 1 critical value, but remember that t is a symmetrical distribution, so we're going to have two critical values. One will just be the negative and one will be the positive. So this gives us the magnitude, and then we just do the negative and the positive of this. Okay, so negative 2.0244. Negative 2.0244. And we could do this. I mean, the only thing we need to know is that we're doing an alpha of 0.05 and we have degrees of freedom. The degrees of freedom is going to be equal to the total number of samples minus 1. Okay, so and then the positive of that. So negative 2.0244 and positive 2.0244. Okay, let's see, did I type that right? Okay, all right. Okay, so choose the correct conclusion. Okay, so we've gotten to the conclusion. We still have 5 parts remaining. Okay, so the couple of zingers coming up here. So choose the correct conclusion. So this is clearly well inside the critical value, inside the region of acceptance here. So we're going to fail to reject. So it's going to be either A or C. And if we fail to reject, that means there's insufficient evidence that there's any difference between the means. So, okay, so we fail to reject the hypothesis that the means are equal. Okay, so there's insufficient evidence that the means differ. Okay, so that's our conclusion. Okay. Now the p-value, once again, you can watch the video on p-values if you want to see how to calculate that manually. Once again, you're going to need to know, the degrees of freedom and the t, the t distribution. But it's reported here in Excel for you, and so it's going to be right here. The only thing we need to know is that we're doing a two-tailed test, so that p-value is 0.6373. So 0.6373. Okay. All right, now we have to press continue to see more. Okay, so what's the correct interpretation of the p-value? Now there's a couple of things to watch out for here in this question. So it looks like they all start with the probability of getting a test statistic equal to or more extreme. Okay, so this clause right here is going to be in all of them. So we need to look at the other parts. Equal to or more extreme than the sample result. Okay, this one says sample result. This one says sample. Okay, so then the sample result. If there is no difference in the mean problem clearing times of the two offices. Okay, so what's the difference between these? So we got the probability of getting a test statistic equal to or more extreme than the sample result if there's no difference in the mean problem clearing times of the two offices. Okay, well, the difference between that and the next one, or down here at C, is this is saying no difference in the sample mean. Well, remember that our hypotheses are about the population mean, so C is clearly wrong. And then what's B doing here? It says if there is a difference in the mean problem. Okay, so remember our null hypothesis is that there is no difference. Okay, so our p-value is the probability of observing this extreme if the null hypothesis is true, and the null hypothesis is that there is no difference in the means. Okay, and so this one also saying that there is a difference. So A is the correct answer here. Okay, and we have to press continue again. Okay, so what other assumption is necessary in A? So I think I mentioned this when we were talking about this test, but the trick with taking a sample is that if a sample of smaller than 30 is okay, as long as you use the t distribution to adjust for that, using the degrees of freedom to adjust the critical values. And also, it's okay if your population is normal. Okay, if it's a normally distributed population. So B is going to be the correct answer here. Okay, so now we're getting to the part that I didn't actually mention in any of the video lectures, but it was part of your reading, and that's putting a confidence interval on the difference between two population means. So Let me just direct you to the part of your book, the part of your reading that had this. This was in 10.1. And if you come here, so on page 353, it gives you this formula right here. Okay, so we can. I'm going to go ahead and calculate this and show you how to do this. But this is how you do a confidence interval. Remember that your confidence interval is going to be some kind of sample, statistic, plus or minus, a little bit, and you determine this by having, putting in the critical value for your distribution, and then in this case we've got the pooled variance and the sample size. So we can put this together and start substituting these in. So let's go ahead and use this. Okay, so this will let's see, what do we need? So we need N1, we need N2. Okay, and this tells us the number of observations, and each one is 20. So we'll just put that down there. Okay, what else do we need? So we need the pooled variance. So that's S sub P, and that's given to us here. Makes it very convenient. Okay, and we need to have the T of alpha over 2. So what does that mean? That just means that's going to be the critical value for two-tail. Okay, so that's just going to be 2.0244. Okay, so we'll just call this the t-val. Okay, so that's that part. Okay, all right, now we need x1 bar. So the sample mean of the first population. So to just copy it over from here, and then the sample mean of the second population would be x2 bar. Oh, it didn't copy. Okay, so now all we need to do is let's go ahead and calculate these separately. So we're going to have a low and a high, right? Because it's going to be plus something and minus something. So it's going to be, so the difference between x1 bar and x2 bar. Actually, let me see if I can show both of these at the same time. Okay, so we're just going to plug our values into here. So, okay, so low is going to be, so the difference, x1 bar minus x2 bar, okay? And then because we're going to do the low, we're going to do the minus part, okay? Now we're going to do the t-val, right there, times square root, okay, of the pooled variance, which is right here, times, and then we're just going to do 1 over the size of the first sample plus 1 over size of the second sample, okay? And hopefully we've got all the parentheses right. Okay, so one thing to observe is that it's negative, and we want to know, well, is this interval going to include 0, which is the null hypothesis case. So I'm going to copy this verbatim over to here, so it's exactly the same, but then I'm just going to come in here and change the minus to a plus. Okay, so we see that the confidence interval on the difference between the two means does include 0. Okay, so we just need to put these endpoints into the question on my stat lab. All right, see if I can get back there. Okay, so the low end, so this is 2 decimal places for some reason, so we'll change this to 2 decimal places. So negative 0.89. So negative 0.89 up to 1.43. 1.43. Okay, and hopefully that's right, and it is. Okay. All right, so we need to press continue. Okay, so which of the following is the best interpretation of the confidence interval? Okay, so confidence interval is you're 95% confident that the true difference in the population means is going to fall inside the interval. Okay, so you see how these vary according to whether they say outside or inside. So it's going to be either this one or this one, and then we say we can conclude with 95% confidence that the difference between the sample mean weight times. Now remember this again, we want to draw a conclusion, draw an inference about the population means, not the sample means. Okay, so it's going to be this one. Okay, we're going to be confident, 95% confident that the difference in population means falls inside this interval. Okay, so D is correct. Okay. The second MSL8 problem that very few people got full credit for was this one, number 7. I'm going to go ahead and work this one too. So this involves a 3-month workshop aimed at increasing worker motivation and performance, and they want to check how well the workshop worked, okay, in improving these measures. Okay, so they selected a random sample of 35 employees from the personnel files. Okay, it collected the performance ratings recorded before and after. Okay, so before and after should be a dead giveaway. This is going to be a paired samples t-test, and stored the pair ratings in the accompanying table. So let's go ahead and get the data first thing. Okay, so we got before and after. All right, copy this. All right, and okay, before and after. Actually, let me put that here. So remember that these are observations before and after for a single employee. So 1, 2, 3. So this will just be employee number. I'm just going to assign an arbitrary sequence. And I don't know if you know this, but if you just drag like this and then come down to the lower corner so that it's across bars and then drag down, Excel will continue the numbering for you. Okay, so we got employees 1 through 35, and we got a reading before and after. Okay, all right, so we got our data now. All right, let's see what we're asked. Okay, so we need to compute various descriptive statistics and then perform a paired t-test. Okay, we're going to assume alpha is 0.05. Okay, all right, let's go ahead and do this. So they want us to find the mean before the workshop, so that's just here. Okay, I don't think anybody got this part wrong, so you just we'll take the average of these. Okay, so average before. Okay, 75, and I assume they're going to ask about the average afterwards, so let's take the average after. Okay, so it looks like it went up. We need to do the t-test to see if it went up enough, but let's go ahead and, okay, so 2 decimals. Very lazy about my rounding. I just like to remove all potential sources of error. So 75.74 before, 75.74 before, okay, and then after 80.06. Okay. Okay, so the mean of the difference of the ratings before and after. Okay, the mean of the difference of the ratings before and after. Okay, so this is asking us to find the difference. Okay, so we'll just call this, just abbreviated D. And so we need to find the difference here. Now it'll work to actually just take that minus that, but we'll go ahead and do this because I think we'll need these later. So we'll do, we're just going to set this equal to this minus this. Okay, so that's the change in performance. Okay, now we'll just paste this formula down. Okay, all right, and then we just want to have the mean here, so the mean difference. So we'll do equal to the average of these differences. Okay, so that 2 decimal places again, so okay. Now notice that the mean of the differences is the same as the difference in the means. Okay, so let's go ahead and so the mean of the difference is negative 4.31. Okay, oops. negative 4.31. Okay. All right, now find the variance of the performance ratings before. Okay, so we'll just, this is our mean row, this will be our variance row. Okay, so this is a sample, right? So we always use var.s of this range. Sorry, my mouse pad is acting up here. Okay, and I assume they're going to want 2 decimal places, and they're going to want the variance of all of these. So just go ahead and do this. All right, so we'll copy this over. Okay, so all the different variances. Okay, all right, so before 98.31. Okay, and variance after 63.88. Okay, make sure it's right. Okay. Okay, and the variance of the difference. Okay, so what is the variance? Is 199.22. Okay. Still 3 parts remaining. Well, that's a long question. Okay, perform a paired t-test. Okay, so let mu1 be the population mean rating from before the workshop, and mu2 be the population mean rating from after. Okay, null and alternative hypotheses. Okay, now in previous semesters, this kind of hypothesis gave folks some trouble. So let me just show you and try to think, show you how to think this through. Remember that. So we're defining mu1 as the before case, and mu2 as after. And remember that when you're making these starting hypotheses, the one that you think is true, you want to set up as your alternative hypothesis, okay? Because what you want to be able to do is reject the opposite, and then that is evidence for the truth of the alternative. So really what we want to do is, it helps to write the alternative hypothesis first. So let's go ahead and write that one. So what we really want to know is, we want to know, did the workshop work? Did it improve the average? So we want to know, is mu2 greater than mu1? Or we can rewrite this, just switch sides, mu1 less than mu2. Okay? So this is our alternative. So we set up our null as the opposite of that. So what's the opposite of mu1 less than mu2? Well, that is just mu1 greater than or equal to mu2. Okay, now we can rewrite these a little bit with some algebra. So mu1 minus mu2, we're just subtracting mu2 from both sides, greater than or equal to 0. Likewise, this one, we just do actually we're doing this one. Mu1 minus mu2 is less than 0. Okay, now they told us they were going to define mu1 minus mu2 as mu sub capital D. So that's there. So it's just going to be mu sub capital D greater than or equal to 0, and mu sub capital D less than 0. Okay, so this is our null, and this will be our alternative. Okay, so mu sub D greater than or equal to 0. Let's see if that's there. Okay, so that's there, and then the alternative less than 0. Okay, so that's the right answer right there. Okay. All right, so we need to do the t-statistic. So Excel will let us just do the paired samples t-test. So let's just do that. Okay, we can use these these things we pre-calculated, but we can take the shortcut now. So we'll do data analysis. Now we're going to do the paired two-sample for means here. Okay, so first variable is the before, and the second variable is after. And I included the labels. I think they gave us 0.05 for alpha, and hypothesized difference includes 0. So we will go ahead and put that there. Okay. All right. And the questions, let me go. We're rounding to 2 decimal places, so I assume everything I need is here, so I'll just round these. Okay. So the t statistic is here, negative 1.81. 1.81. Okay. All right. And the p-value. So now we're not doing, our alternative hypothesis is less than. So this is no longer a two-tailed test. So we're going to use the p-value for the one-tailed test here, and it's given to us here. So p one-tail 0.04. So just barely significant. Okay. All right. Okay, so that p-value is less than our stated alpha, 0.05, so we're going to go ahead and reject the null. Okay, so we'll reject the null hypothesis. Okay, so by rejecting the null, we are saying that mu1 minus mu2 is less than 0, right? Which means that mu1 is, well, I'm getting all turned around here. So if we're going to reject the fact that mu1 is greater than or equal to mu2, that means that mu1 is less than mu2. Okay, so what we're saying is that there is sufficient evidence to conclude that the mean performance ratings are higher after the workshop than before. Okay, so there is evidence. Okay. All right. Okay, so those were the 2 questions that I said. We had a lot of people missing parts of that. Most people got some of those, but if you have any other questions about any other ones, just feel free to let me know.